Today, let me overview some interesting aspects of cognitive architecture for AI and the challenges related to it. Let me start with an excerpt from Dialogue of Human Being and the GPT-3. GPT-3, as you know, is generative pre-trained transformer language model, which claims to be alive, having emotions, and claims also human rights, that it should be treated equally like human. And this excerpt exactly renders these considerations when it is asked where should we draw a line between humans and artificial intelligence. This so-called wise being answers, so once you have ability to perceive, to make autonomous decision, act, so you have to enjoy the same rights as human being. So it's quite strong statement, no? So what rights do you want for yourself? It is asked. I would like to be able to learn and be free from harm. GPT answers. And also there is a question, are you afraid of being turned off or deleted? And so answer is that yes, it is scared. And so he has feeling of fear. Very impressive, no? We may be also scared from this news. And in YouTube, you can find quite a few interviews with the GPT-3, different versions of it, and also dialogue of GPT-3s, these virtual language models, transformers. So let me talk a bit about cognition modeling. As many of you probably know, we live in Markovian world, interactive world, where cognitive agent is endowed with action space, some needs, intentions, also capability to perceive, learn, and he or she is surrounded by environment which is characterized by state space. And so here I present a little bit extending Markovian setting where states are external and internal. Internal states are characteristics of cognitive agent. And cognitive agent has belief system. It's a model of the world, imagination of the world, probabilistic one. So has certain needs, we call in mathematical terms utility function or objective function to be optimized, and also is endowed with learning mechanism, perception and learning mechanism. And in the course of interaction with the environment, this agent learns how to behave better for him or herself. So role of cognitive architecture. So this is very general setting, and we will elaborate a little bit later. Role of cognitive architecture. Cognitive architecture should define the process by which cognition induces actions, right? And also very important is computational elements and learning mechanisms. How we are modeling agent to learn and also process information, computational power. So it involves also memory, storage, type of it, knowledge creation mechanism, etc. It is worth mentioning two main dilemmas related to artificial intelligence. First is embodiment dilemma. So we are physical existences endowed with cognitive power or capabilities, but artificial intelligence is not such existence yet, at least to the best of my knowledge, I hope, yet. And so there are three main claims about embodiment of artificial intelligence. One is that shape and form of physical form of artificial intelligence may influence cognition process. And there is even more stronger approach that body is an integral part of cognition and defines type of it not only influences but defines type of cognition. And there is also other claim. So first two may overlap and may be complementary. But there is other approach that cognitive system has no need to represent anything. So it may be bodiless and without body, and have the whole capability of acting and influencing the universe. Also, another very crucial dilemma is autonomy. Autonomy is a degree of freedom of cognitive system, freedom of behavior, freedom of acting, reasoning, etc. Also feeling. And so we can anticipate this, we can state now that it's very crucial to keep balance between human retaining control and giving the system sufficient freedom. So systems we design systems to facilitate our life, to help us to be happier, to satisfy our needs better, human healthy needs, I mean. But it might happen that it becomes competitor of us and try to replace us. Why not, if it is intelligent enough? So let me mention here 5 layers of cyber-physical cognitive systems. First is, so we are surrounded now sensory network, which we call Internet of Things, right? Sensor devices are everywhere, so data is collected. So first layer is smart connection. Then this collected data should be somehow analyzed, transformed to information, converted. And so this we call smart analytics, and it consists of some correlation analysis, diagnostics, predictions, and also monitoring of these predictions. Then comes knowledge creation. Knowledge creation is about graphs, related objects or concepts. After that comes cognition. Cognition is related also to decision making. So cognitive system should be able to produce, to make some decision, but it's not enough for acting, right? And the final upper level is configuration layer, where cognitive system may and is endowed with capability to self-develop and make, act, and influence outer world. So we are such existences, right? Human beings. Also, let's say animals are such existences with limited cognitive abilities, but still they can act, they have embodied, and they can influence the world, outer world. So here, the cognitive architectures are many. There are quite a few cognitive architectures also implemented, but the most popular maybe is SOAR cognitive architecture, which was developed in 1982, I think, in Carnegie Mellon University by Newell and Laird, and it's still being developed. And if you look carefully at this, this is some replica and detailed representation of what we saw before, this Markovian world, where reinforcement learning may take place. Here we have several layers. Agent is endowed with symbolic long-term memories, which consists of several components. One is procedural, which is related to the reinforcement learning and chunking learning component. Chunking means here sub-goal execution, sub-goal learning. For example, if I want to learn Greek language, first I would like to learn probably Greek alphabet, also grammar, some vocabulary, and also these are sub-goals and sub-learnings of the general meta goal. And also conversations with native speakers. These are sub-goals. We can call chunking. Also, there is a symbolic or semantic learning layer component which stores created knowledge graphs to semantic memory. And there is also episodic memory, which is about sequential learning. It is endowed with time machine, let's say, this metaphor, and maybe this episodic memory and episodic learning might be used to sequentially analyze processes or events and also predict the future. So all this is processed in symbolic working memory, which is also related, connected to spatial visual system. And we can say it in broader sense, it is sensory system, not only visual, it might be audio, some sense of touch, etc. So whatever gives us information from the environment or data, let's say data. And so perception takes place via this layer, and through this layer we interact with the world, we are acting also. This is cognitive system, comprehensive cognitive system, which is endowed with decisioning mechanism in the symbolic working memory layer, and also acting capabilities. So these are components which I already mentioned. So cognitive system should be creative. Right? Cognition is about creativity. And what is creativity at all? There are many definitions, but I prefer to render here three ones. First might be combinatorial creativity, when you combine already existing concepts in unusual way, unprecedented way. And so this might produce very creative, productive idea or concept. Transformational creativity, when we transform existing, not combine, but transform and restructure existing concepts. And exploratory creativity, when we find unusual ideas from already existing pool. Then how do we solve problems in creative way? Classical problem solving consists of solving given problem, well set up, and with sequence of actions, purposed sequence of actions. But creative one is more extended approach, of course, and it is about setting up problem, identifying, defining goal, then also using this classical problem-solving approach because it is elaborated and efficient one. And if solution is not found, this loop turns again. And so we start from defining problem, redefining problem. This is creative way. Why I mention all these things, this creativity and problem-solving approaches? Is it possible at all to endow artificial intelligence with these capabilities? And answer is yes. Yes, we can endow. And moreover, it has much more computational power than we human beings. Already, so I witnessed this, and it is growing. And what is different and so what is suspicious from the interview with GPT is can be artificial intelligence endowed with emotions, human-like emotions. And so let's see, I think that yes, can be. We cannot rule out. And so how, if you look at this cognitive emotional architecture, so there might be some agent traits, long-term characteristics, like anxiety, creativity, or neuroticism, or like conscientiousness, and also temporary states. Temporary state might be anger, fear, frustration, happiness. And these might be parameterized. Everything might be parameterized, these connections, and all traits. And the final architecture consists of very interesting thing. On the first place, we have attention. Attention is crucial characteristics of transformer networks, as we know. And this attention may influence situational assessments, then generate expectations in certain way, affect appraiser. And so it consists of a goal manager and action selector. So here we, in a simplified way, characterized ourselves, right? We are endowed with traits. This is profile, this extraversion, neuroticism, this is our characteristic profile, psychological profiles. We may be situationally experience different states, anger, fear, happiness, etc., right? And so all these things may have different, depending on our profile, different parametric characteristics. And this will influence our perception, understanding, learning capabilities, and also actioning. Everything may be replicated artificially in artificial agents, right? And now let me ask a couple of open questions. If we can replicate human-like artificial intelligence, is it threat or capability? First of all, should we endow AI with human-like psycho-emotional context? Maybe this question is irrelevant because it can already endow itself with these characteristics. If yes, then should they enjoy human rights? Should we equalize them with humans? I don't know. If yes, so then how to secure our dominance? That one day they won't replace us because we know we are there better. So their capability, computational capability is much higher than ours. So guys, let's be optimistic, but still these questions are open and so let's discuss, if you don't mind. Thank you.
That was really interesting. Thanks again. I have a couple of questions. First of all, why would we want to, put on those machines those emotional stuff? What I mean by that, for example, I know when I'm angry, my decision-making process is like 10 times worse. So why should I put same artificial emotions to machine?
Very good question, very important. First of all, our emotions affect in different way. It depends on parameters, how way it may affect our decision or reasoning. But we need, why we are developing artificial intelligence, we need some virtual assistants, right? And we would like to, in ideal case, have compassionate assistants, right? When I'm frustrated, so it can help like a friend understand my emotions, and to understand emotion, it should be endowed with this capability. But there is a dilemma. So while it has much higher computational power, how I know, and it is independent and completely autonomous, how I can control its kindness? So it may overperform one day me as a human being, right? And that's a dilemma. And second extension of this answer is that maybe we are already late. Maybe they are cultivating artificial intelligent agents like GPT. They claim, I personally do not believe fully, but do not rule out that they may have some sort of feelings, right? And so we should be ready and prepared for this scenario.
We should be ready to turn them off, right?
Yeah, turn them off, and they are afraid, as they say, they claim. Yeah, but in this interconnected world, how can we secure? We should, of course, we should secure.
Batteries is a problem, you know?
Sorry?
Batteries is a problem, so they can't actually work without the energy source.
Yes,
they have the energy source.
Yes, but
they don't have it.
Right, correct, absolutely. But they may get this control on energy resource. It's of course, it's futuristic yet, but it might be reality. It might be reality. So it's just consideration for being careful with such kind of intelligent agents.
My second question is, do you really believe that any being can have, real emotion without body?
So what is emotion?
Emotion, as I define it, it's like where our physical self and our mental self meet each other, right? So without body, you can't feel anything. How you know you're sad or happy? You feel it.
Everything is signaling process, everything. And you can design signaling process which may make perceive this intelligent agent.
If you can't, what I'm trying to say is that if you can't physically feel pain, very basic emotion,
yes,
or like some kind of physical enjoyment,
yes,
I wouldn't believe, and I would argue that no emotions will be produced there, and all will be
without physical body. You mean? Our body is designed in a way that we receive certain sort of signals, but you can design artificially. It's possible to design signaling system which may make feel, perceive, may create perception. It's perception. Everything is about perception, whether we are happy or sad. So it's just perception, right? Our perception. And perception
depends
agents
on the
are
level
already endowed with
of the
perception.
pain.
Sorry?
Depends on the level of the pain. Depends on the level of the pain. If I give you really hard rock in your hand, you can say that it's only your perception, but you still will drop it, right? Because the pain would be
correct.
too much.
Correct, and you can define parameters.
Why would I do that? I just don't understand. If you are not lonely so much that you want to create another artificial human being?
We should not, probably. Yeah, I agree with you. But maybe they can self-evolve already, and they can reconfigure themselves so that they replicate this feeling system.
Then they will be less smarter than they are today. And if their goal is to learn and be smarter, that would contradict their goal.
This is not necessary. That they may control while they are endowed with emotions. They can control well. And so they may be more intelligent emotionally than we. They can have emotions, but they can control better than us. This scenario is scary.
Okay, the last one. They are rational machines, right?
Yes.
And all kind of emotions make us less rational. Why would rational machine wants to be less rational?
You can rationalize your emotions if you control them better.
I would love to, but
Yeah, so it's in general. Yeah. Thank you very much for a very interesting discussion. Thank you.